In order to understand this lecture, you have to first view lecture 17a part 1. Here's an enlargement of the previous superficial geology map. So here we just see southern Alberta. And what I want you to note here is that there is actually only one area which has the ice thrust moraine. So that's this particular green. And that is approximately the maximum extent of the Laurentide ice sheet during the late Wisconsin. Then we have a retreat and we have a stagnation where, for example, you can actually see here the lobe of the ice sheet, where along the edge we see actually the Hamakua moraine region, and this includes that Hamakua moraine region just south of Lethbridge, around the airport that I showed you earlier. At the same time, we also see some activity from the Cordilleran ice sheet. So the ice of the Cordilleran ice sheet was actually flowing this direction. So we also have some ice tongues spilling out from the Rocky Mountain areas. So for example, there's gravel pits around Fort McLeod that here, gravel pits that are the result of an ice tongue ending in a glacial lacustrine lake and forming a delta in this region, in this whole Fort McLeod region. What you also find here is some of the glacial fluvial deposits that are on the virtual field trip that actually formed the Kame terraces. So that's just like a little summary of that in relation to some of the material that you've already learned in some of the previous lectures. But the color that you see in blue here is all the regions where the ice marginal lakes were forming the glacial lacustrine deposits. And glacial lacustrine deposits are basically lake deposits, so they're horizontal lake beds that are alternating silt and clays. Some of these lakes you see here had kind of their overflow region, or called spillway, is the cause of some of these coulees being formed. So as you know, some of the coulees are actually now completely dry. Some of the coulees actually still have a river like the Altman River flowing into it. So for the next slide, what you can see here is during the stagnation about 14,000 years ago, we basically had one of the lobes, the Lethbridge lobe of the Laurentide ice sheet, was actually positioned a little bit over kind of West Lethbridge, so not South Lethbridge, and because it was then diverting the pre-glacial rivers. The pre-glacial rivers were all flowing kind of roughly east to west, west to east. So this west to east. And if you suddenly like encounter an ice lobe, you basically then have to divert around the ice lobe like this. And this is where basically the Lethbridge coulee, the Altman River, is actually flowing right now. And you sometimes notice when you go over the bridge that the gradient of the river is so low that you sometimes, when there's strong wind from the north, you don't even know that the glacier is actually flowing towards the north. So obviously if you go from this location to this location with a straight line, then the gradient is steeper than if you have to like go all the way around that lobe. So that's a little explanation about why the river is actually flowing relatively slow. But now let's actually zoom in to that Lethbridge, the area of that Hamakua moraine region just south of the airport. So here's the airport of Lethbridge. Here's that hummocky moraine region where you see this area bounded by these lines here was basically the edge of the ice. So the maximum ice extent during that period was here. And we have a stagnation, and that ice, which was probably quite crevassed, was actually like laying down in this region and made these shapes a little bit like a cookie cutter, and very, very soft dough can actually like make all these hills with the dimples inside. So there's a good paper by René Barendrecht and colleagues that I have put on your Moodle site. So here is an example of deformed tills that were subglacial tills. This is found around the Travers Reservoir region, which is north of Lethbridge. And what you see here is till, obviously, is a very poorly sorted sediment that has, in some regions, some larger blocks in it, and then a matrix of finer sediment. So this is a matrix supported till here. But you can also see some folding in these sediments, as you can see over here and here, for example, curling around. So obviously the till in the deglaciation phase, there was a lot of meltwater, so the till was actually quite weak. So any movement over the till would actually deform this till. So this is a deformed glacial sediment till, but we also have good examples of glacial tectonite. So now we see sediments that were deformed by the ice, but they were not transported and deposited by the ice. So what we see here is a glacial tectonite and not a till. And here we see that bear paw shale that we actually saw on the one of the first slides over here. So you see the darker shale or former clay layers, and then the lighter siltstone layers. That isn't completely bedrock yet, as I explained before. So once you pump in a lot of water under pressure, it can still be very deformable. And here we actually see like how the glacier was probably flowing from the right to the left and like dragging part of this bedrock with it. So in some regions, this is around Bow Island, so just a little bit east from Lethbridge, we can actually see that glacial tectonite that can be 10 to 15 meters deep. So the ice was actually resting or moving over top here, and then it deformed 10 to 15 meters of this sediment. Now what you see here is that the top of that bear paw shale is around here, and there's also some fluvial glacial sediments, some glacial outburst flood sediments being deformed as well. So obviously these ice margins were retreating a little bit, advancing, retreating a little bit, advancing. So sometimes you have proglacial sediments that are then overridden by the ice again and deformed by the ice again. This is that Bow Island section site, one of the actually a really good example of glacial tectonites. There's people from all over the world, quaternary geologists, that are actually coming to southern Alberta to look at these beautiful folds, as you can see here in the bear paw shales, and then some of the outburst floods actually had these big gravel legs, and then like finer gravel when going upwards when the water flow in these outburst floods, the Eucalyptus, was actually diminishing. And sometimes some of the sandy beds have beautiful folds as well, and there's some faults in here too. So when you analyze folds and faults, you have to realize you can do the same principles as you actually used in your analog model. So we can also look at the stresses and strains on it, and from the reconstruction of the direction of the folds and the faults, we can sometimes reconstruct both the activity of the ice and the direction of the ice movement. So this is the end of part A of this lecture.